We're now going to take it a step further in 6.2 and look at radicals that have to be multiplied first and then simplified. So kind of taking the skills from the previous two videos and putting them together. So we're going to start by multiplying them together. So when I multiply, I'm going to multiply my numbers together first. So 72 and 10 is 720. And then when I multiply my variables together, I'm going to add exponents. I'm going to write that down. I'm going to add exponents when I multiply them because that's my exponent rule. So x cubed times x is x to the fourth, and x squared times x, or y squared times y to the third is y to the fifth. And now that whole thing is being square rooted. Now I want to break it down. So now I'm looking for the greatest perfect square factor that goes into 720. So I need to grab a calculator. Let me see. Does 720 divide evenly by 144? Oh, it does. First try. I do like to start with the higher ones to help me. So it is 144 times 5. So I'm going to put a box around the 144. X to the fourth is already perfect because 4 already is divisible by 2, and that's what the root is. So I'm going to put a box around that one. And then y to the fifth is not perfect because 5 does not divide by 2 evenly. So I'm going to break it down to y to the fourth and then a leftover y, and I'm going to put a box around that. So everything that is perfect, I've put a box in. I'm going to take the square root of each of those. The square root of 144 is 12. The square root of x to the fourth is x squared, do power over root. The square root of y to the fourth is also y squared. And then left under the radical, I have a 5. I don't have any x's, and I have a y. So that is my answer. Next one, I'm going to multiply the numbers together first. So I get 45 times 2 is 90. And then when I add my x's together, I get x to the sixth. And when I add my y's together, I get y to the sixth. So I'm looking for a perfect square that goes into 90. That's going to be 9. It's going to be 9 times 10. And then with your x to the sixth and your y to the sixth, those are both already perfect because remember, your root is a square root. So it's a root of 2. Both of their exponents, since they're both 6, are divisible by 2. I'm not going to have a lot of leftovers here. I take the square root of 9, I get 3. I take the square root of x to the sixth, I get x to the third. The square root of y to the sixth, I get y to the third. And I still have a 10 left over under the radical. Last one's got a little extra going on. When we have coefficients, and we talked a little bit about this a couple chapters ago, anything that's outside of the radicals that's being multiplied, we are allowed to multiply those together. So you can take the 3 and the 2 and get a 6. Then I can work inside. So now when I'm working inside, it's a cube root. 5 times 50 is 250. Y to the third times y to the fourth is y to the seventh. 250 is not a perfect cube, but 125 is, and that goes into 250. So I'm going to put a box around the 125. Y to the seventh is not a perfect cube, but I can break it down into y to the sixth because 6 divides by 3, and then a leftover y. So I still have the 6 out front. I'm going to take the cube root of 125, which is 5, so I'm going to bring that out front as well. And then the cube root of y to the sixth, which is y squared, I'm going to bring that out front. I still have inside a 2 and a y, so I still have the cube root of 2y. My last step, I did have an extra piece with this. I had a 6 that was out front, and now I have a 5 also out front. Now I'm allowed to multiply those together. I get 30y squared times the cube root of 2y. So that's taking you through how to multiply radicals and then simplify. I think that's the last, that's the last multiplying one. So that gives you a better understanding of how to start these and then how you finish them the same way as ones we had finished before.